In this presentation, we're going to be looking at 3 new tools for effects artists working in Maya 2013. We'll look at Maya NHair, the Bullet Physics Engine, as well as Alembic caching. First, we're going to start with Maya NHair, which is a realistic hair or curve-based dynamic simulator built on top of the Nucleus framework. Nucleus is Maya's unified simulation framework, so what this means is NHair is fully integrated with the other N modules, such as N-cloth or N-particles. This allows it to bidirectionally interact with these other modules. So we're going to be using this to generate a hair system on my girl. I want to make a ponytail that's dynamically solved using NHair, and this is very fast and easy to do inside of Maya. All I have to do is grab a piece of geometry and create an NHair system from it. If we start our playback, you'll see that obviously that hair begins to drop down, and that's because the Nucleus node has a gravity system built into it. Notice that it passed right through the back of the girl, as well as the fact that the hair isn't really preserving any volume. So those are the first 2 things that we want to address. We'll just grab this piece of geometry and we'll create another N object from it. In this example, just a passive collision object. Now if we start our playback, you can see that that hair comes down and it'll bounce right off the girl's back. So problem 1 has been solved. The next thing that we want to do is we want to start using some of the NHair attributes to massage the overall look and feel of this ponytail. And this is very easy to do. The first thing that we're going to do is turn on self-collision. And this is one of the advantages that NHair has over the classic hair that was included in Maya previously. The collision engine is much faster than it used to be, as well as much more sophisticated. It can do things like collisions based on edges, as opposed to just vertices. As soon as we turn on self-collide, you can see that that hair kind of puffs up, and that's because of this self-collision thickness that we have. Now we can use that in conjunction with some of the classic modifying tools that the hair system has inside of Maya to adjust the overall look and feel of this. So if we increase the clump width and start to use this ramp modifier to adjust the shape of the hair down the length of it, we can start to get maybe sort of near the root it's very thin, and then it kind of puffs up in the middle and sort of tapers back off. So using these basic tools to massage or finesse the overall look and feel of this hair system is very interactive, and we get this really nice look and feel to it extremely quickly. I'll just use a preset to further dial this in. So we change the color, and I puffed it up a little bit more, made it a little bit thicker. So the next thing that we want to do is use some of the constraints to help us further style this hair. When working inside of any of the Nucleus modules, you have a series of unified constraints, fields, and forces that you can work with. And this really helps you learn the tool. So if you know how a constraint works with N-cloth, it's going to work very similar with NHair. So what I want to do is I want to constrain the end of this hair. So we'll grab the N vertices of those hairs, and I'm going to create a new N constraint. And this is a pretty simple constraint. It's just a simple transform constraint. So obviously if we play this back, those points are going to be stuck in space. And I can use this transform constraint to start to do some pretty fun things to help me style the hair. If I start to want to maybe introduce some twist down the length of that hair, notice that the volume is preserved. If I start to interactively move this back and forth, you can see that very complex self-collision interaction that's happening with that volume being preserved. So another thing that's worth mentioning is all of these constraints have a glue strength, and this is a threshold. So once that threshold gets exceeded, that constraint can turn off. So if I start to drop this down, you can see that that hair starts to sort of peel away. Maybe I grab my character and start to interactively move her around here. I'll break that last little bit. So in this example, what we're doing is we're actually moving a human IK system. So this is a full body inverse kinematics rig that we're updating in real time. Very, very sophisticated self-collisions happening, as well as that collision with that passive N object. And it all happens basically in real time. And you can see the quality of the solve that we get is really, it's phenomenal. So let's go ahead and reset this, and we'll talk about the last thing that we wanted to highlight with the NHair system, and that's the ability for it to interact with other N objects in the scene, such as N particles. So let's go ahead and get our N particle system in our scene. Let's go ahead and create a simple emitter, an omnidirectional emitter that's spitting out water particles. Let's go ahead and, looks like I didn't get that guy. Let's say create an emitter. Let's go and position that guy up here, and we'll play this back. So as this plays back, you can see obviously that emitter is kind of coming down here. It's starting to add a little bit of particles into the scene. Some of those particles are getting stuck on that hair. If I move this girl around, you can see the bidirectional nature, so those particles start to get pushed around by that hair. We can also use those N particles to actually start to break this hair. So let's go ahead and change some of the attributes on these. We'll just go to the N particle shape. I'm going to turn it into a stream of water, essentially. And what we'll do is we'll just grab that emitter, position it over here, go to the interactive playback mode. So we've got that constraint. I've already dialed down the weight of it, but you'll notice as I start to pull this in emitter across that hair, As those particles are kind of a little bit heavier now and they start to interact with that hair, you'll really get a sense of here they come, they hit the hair, and they basically break that constraint as I wipe across here. So this really clearly illustrates the power of these bidirectional natures between in particles, in hair, using the in constraints to sort of tag that hair up there to hold it back in the beginning. And that's what it's like to work with the new in-hair system inside of Maya 2013.
So let's go ahead and look at Bullet. It features discrete and continuous 3D collision detection and enables the simulation of both soft and rigid bodies in a single system while using a rich set of constraints. The first thing that we want to do with Bullet is use it to generate some dynamic secondary animation on this character's tail. So we'll go grab the joints of the character's tail and create a ragdoll from them. Basically what Bullet's done is it's gone through for each joint and created a collision object and then joined those collision objects together with constraints. The constraints have the ability to look to the original skeleton's limits to adjust how much movement they're going to have. That combined with dampening values goes into making the overall look and feel of the ragdoll. So let's go ahead and clean up our display a little bit and play back our animation. And you can see that we now have this cool dynamic secondary movement on the character's tail, but it's passing through the ground plane. So this is the first thing that we want to fix. And we're going to do that by creating a new rigid object in our scene. This time it's going to be a static rigid body that's just an infinite plane. So obviously now if we play it back, the tail no longer passes through the ground. Next, what we want to do is create a relationship between the skateboard and all this trash. We're going to create active rigid bodies from all this based on the mesh. So let's go ahead and just grab all these pieces of geometry and create, get that guy too, create more rigid objects in our scene. So now that we've made those active rigid bodies from those meshes, if we play back our animation, you'll see that there's a couple problems. First, the skateboard drops to the ground, and notice the movement of these objects. They're kind of floaty. So what we want to do is fix both of those problems. It's really simple to do. We'll grab the skateboard and we're just going to switch the type of rigid object that it is. Instead of being dynamic, we're going to push it back into a kinematic rigid body, so it's going to go along for the ride of that original animation. I'm going to go and grab the solver and increase the gravity so that those objects don't look quite so floaty. So now if we play this back, notice the effect on the tail. It's getting sucked down because of that higher gravity and those objects no longer float. So that simulation looks pretty cool. There's still one problem. We have a bag of chips that's floating up here in the sky. So what we're going to do for that is create a soft body. So we'll go and create the soft body of the bag of chips. And I want to change a couple of the parameters for this soft body. And I'm going to use a preset to dial it in. Essentially all I've done is increase the stiffness a little bit, the resistance a little bit, and I've turned on volume matching, so it's going to try to maintain a little bit of that volume. So now if we play this back, notice the interaction. When that comes down, the soft body collides with the rigid body, and it's a very cool dynamically driven simulation. The last thing that I want to do is just increase a couple of the attributes on these tail rigid bodies. I'm going to go and give them a little bit of push up in Y. So we'll just put a little Y impulse on those, and we'll play this back one more time. So this really is what Bullet's all about. Soft bodies interacting with rigid bodies, constraints holding together collision objects, generating ragdolls, all happening very, very quickly and interactively inside of Maya. Next, we're going to look at Olympic, and we're going to use it to generate a cache from an in-particle system that's been meshed, so it has changing topology. We'll go ahead and we'll export our selected object out, and we'll just overwrite this file. Olympic was co-developed by Sony Picture Imageworks and Lucasfilm. Olympic distills complex animated and simulated data into a non-procedural, application-independent set of baked geometric results. Efficient storage of the computer results facilitates high-performance reading and writing. Massive data sets can now easily be passed between disciplines, such as animation and lighting, or animation and simulation. This reduces the overhead and loss of interactivity associated with transferring fully editable data scenes. So now that our cache is done, we can go ahead and hide our original in-particle system and just re-import in that newly generated Olympic mesh. Let's bring that guy in. So now that it comes in, notice the interactivity and the speed at which I can play around with this file. Because it's just a simple cache result, I'm no longer dealing with the overhead of that simulation. So this is going to allow you to really pass information back and forth around your pipeline in a much more efficient manner than previously available.
So that's just a few of the new tools that are available for effects artists working in Maya 2013. We saw In-Hair, the Bullet Solver, and the new Olympic caching file format.